Hi guys, welcome to our video lesson number 2. This time we're going to delve a little bit deeper into our electric fields, and basically we're going to have a little bit of a look at field lines and different shapes and things like that. So here we go. Now, what is an electric field? An electric field is said to exist in the region of space around a charged object. So the charged object is the source of a charge. So if we were to charge up one of the spheres in the physics lab, that would be the source of the charge. When another charged object, which we call a test charge, enters this field, an electric force is acting on it. So it's going to feel something. If we are wanting to draw electric field lines, there's a few things that we need to be aware of. So the first one is the direction of the lines of force. So electric fields are represented by using lines of force, and lines of force show the direction and the magnitude of any field, of the field strength at any point in time. So here we have a little diagram, and it's showing some field lines, and they're closer together here, and they spread out down this end. So that's going to show us the magnitude by how close together they are, and it's going to show the direction because it has these little arrows down here as well. So magnitude and the direction. If we want to draw field lines, and the more dense they are, as I said, the electric field is going to be stronger where they're closer together. So here we've got a little bit of a diagram demonstrating some density. Around charge A, we've got some sort of uniformly spaced lines. There's not many around there. Charge B has got a few more, and charge C has got heaps. So what we can tell about that is that the charge on C is going to be the biggest, or it's going to have the biggest magnitude of charge. It's going to be bigger than the charge of B, and B is going to be bigger than the electric charge of A. So we can tell all of that from the field lines and how close together they are. Now there's a few rules we have to bear in mind if we're ever going to draw some lines of force. Now, rule number 1 is that the lines of force are always drawn away from the positive and towards the negative. So that's the main one. So away from the positive and towards the negative. The secondly is lines of force always leave or come into contact at right angles to a surface. So if they're coming out of a circular charge, they're going to be perpendicular to the edge of the charge. They're always going to come out at right angles. So if they're talking about a flat plate being charged, then the lines are going to come directly straight out of that plate. All right, they're always going to be at 90 degrees. And the lines of force can never cross each other. Okay, so that you'll notice when we show some examples that the lines are never crossing. So here's some examples. We're going to go through the types of field lines that you might find around different things. So this is talking about a point charge. So this might be a proton or an electron or just an individual point charge by itself. So it's not interacting with anything else. So here we have a positive charge, and we can tell that it's positive because if we remember our first rule, field lines are always drawn away from positive charges and towards a negative charge. So we can tell right away, just looking at the diagram, that this guy is positive and this one over here is negative. If we have 2 point charges, they're going to start interacting, and it's going to depend on whether they're positive or negative charges. So in this first part here, we've got a positive over here, and a negative charge, and they're interacting. So normally, as we saw in the last diagram, they're coming straight out from the surfaces of each charge, perpendicular. When we bring them close together, they start interacting. And we know that opposite charges attract. So remember our field lines going away from the positive charge towards a negative charge, and as they start interacting, that is going to go straight into the negative one. So come out of the positive and straight in. And as you can see, none of these lines actually ever cross, so we're not breaking any of our rules. Here we've got 2 like charges, and as we said before, going away from a positive charge. As we start bringing them close together, they're going to repel. Alright, so we can't have any lines crossing over. So what that means is that the lines are going to bend. So as you start bringing them closer together where they would normally cross over, we can't have them crossing over, so they bend away from each other. And this is the field lines bending that is caused by the repulsion between the two. Now the only difference, if this diagram was to show two negative point charges, the lines would be exactly the same, except this would have a minus, this would have a minus, and all of our little arrowheads would be turning inwards. Alright, they'd all be going towards the negative charges, but the actual position of all of the lines would be in exactly the same spots. Here we have a hollow sphere. So imagine like a piece of pipe, a metal pipe or something like that that was charged, or a hollow sphere, just a little ring, anything at all you can imagine that might look like that. Now, the first thing to notice is that there's never any charge inside a hollow object. It's only on the outside. All right, it's only on the outside surface. So here we've got our field lines. If the outside is coated in a positive charge, our field lines are going to be moving away or directed away. They're single charges, so they're not interacting, so they're all straight lines perpendicular to the surface of that sphere. And again, exactly the same over here. We've got a negative charge distributed around the outside, and all of our field lines are going to be going in towards the negative charge. Now, when we have objects with an unequal amount of charge interacting, our diagrams become a little bit more complicated. Now, if the quantity of the charge on a source is not identical, the pattern will take on an asymmetric nature. So it won't be as nice and simple as our last diagrams. Now, one of the sources is going to have greater ability to alter the electrical nature. So obviously, the bigger the magnitude of the charge, the more ability it's going to have to alter the surrounding electrical, alter the surrounding space. So what that looks like in picture form is we've got, obviously, looking at the magnitude of this one, it's got less field lines, so it's going to be a smaller magnitude charge than this positive charge because it has greater density of field lines. So when they start interacting, again, we can't get them to cross, so these ones start bending, and you can see it's all sort of getting pushed towards this positive charge because this guy is more powerful. All right, and it's exactly the same pattern and geometric shapes here as the last example. We had two positives, two negatives. The only difference, again, is the two signs and the direction of the arrowheads, but essentially the picture is identical. Down the bottom, we've got two unlike charges, and they're attracted to each other. This positive charge has less density, so it's smaller. This one has more density, it's a bigger, so the negative charge in this example is the big one. And you can see that all of these field lines are trying to get bent towards our negative because they're very attracted to the negative. It's quite strong. And over here we have the reverse. In this case we have a big positive charge and a smaller negative charge, and nearly all of the field lines coming out, going into the negative are getting bent back towards our positive charge because it's so massive. And that's all. Alright, so this is a much shorter video than our last one. We will have a look at some practice of drawing field lines and a few activities to better our understanding of the different shapes and where their charges are in our class next lesson. And we'll also have a look at a bit of a game to try and better our knowledge of charges also. Hope you enjoyed, guys. Make sure you contact me if you have any questions.